Good day, students. You are welcome again to the continuation of your screencast for week 7. Today we shall be looking at differentiation principles. The first principle we're going to be starting with is the product rule. Here we could recall in week 6 we talked about in our lectures the power rule. For instance, given that y equals a times x to the power of n, we remember that the power rule by the derivative says the derivative of y says that we should bring down the power, which is your n times your base there, a times x to the power of, and then you minus 1 from that. It becomes a x to the power of n minus 1. This basic rule will be applicable in all the principles applied here. So let's start with the product rule. How do we apply the product rule? Given, for instance, y equals to u times v, where u is a function and v is another function. The product rule says when we're differentiating, we hold one of the functions constant and we differentiate the other. So if I hold u constant, I differentiate v, becomes dv dx, because I'm differentiating with respect to x. And then also you add and differentiate now your u and you hold v constant. So it becomes v du dx. That is the rule. Now note this, it doesn't really matter which one you differentiate first or which one you differentiate last. Just make sure you differentiate one, you hold one constant, and you add, differentiate the other, hold the other one constant. Let's look at an example. In example 1, it says y equals into bracket x cubed plus 7x minus 1, bracket close, open bracket 5x plus 2, bracket close. Find the dy dx by the product rule. Anytime you're given the product rule, you will often see the functions in 2 or more brackets. Now, how do you apply the product rule? The first thing to do is to hold one of the functions constant, and then you differentiate the other. Let's assume the first function here is our u, and then the second function here, 5x plus 2, is our v. Now, you immediately differentiate them. Let's differentiate u, becomes du dx. If I differentiate that, it becomes 3x to the power of 2. If I minus 1 from that, that's 3x squared. Differentiate that, your x becomes 1, and that becomes 1 times 7, which is 7. Your constant 1 gives you 0. That's one of the rules of differentiation. Any constant differentiation is 0. And then we differentiate the other, dv dx. Differentiate that, the x becomes 1, that's 1 times 5 gives you 5. Differentiating the 2 as a constant gives you 0. So you have 5 as differentiation of that. Now you apply the rule back up there, which is u dv dx plus v du dx. So it means to do that, you cross multiply this. If you do it that way, your u dv dx is there, and your v du dx is there. So if I do that, I'm going to have that. So you see that there, that's my u dv dx, and that's my v du dx up there. And then after that, you open the bracket. 5 times what is in the bracket will give you that. Open the bracket there, using your FOIL, you have that. Collect like terms, you'll be having that. 5x squared plus 15x cubed, 5x cubed plus 15x cubed gives you 20x cubed. The power 2 there is 6x squared only, has no family. And then the power 1 of x is 35x plus 35x gives you 70x. And minus 15 plus 14 gives you 9. That's the answer. Let's look at another example. In example 2 also, here you can see it's a little bit different from the first one. Here we have 3 brackets. You need not have any fear. What is necessary here is that you need to break down these 2 brackets into 1, or you can say the last 2 into 1, so that it becomes 2 brackets. So what I have done here is to say this is my u, which is x minus 1, and I take these last 2 brackets as my v. So I can open the bracket for this, and that gives me that. So now I have 2 brackets, and now I can apply the product rule. So this becomes my u, and then now becomes my v. Let's differentiate u. If you differentiate u, your x gives you 1, and that will give you 0. So it means du dx is 1. If you differentiate that as your v, it becomes 2x minus 5. And that's there. And the next thing to do is to cross multiply your u times dv dx and your v times du dx. And that's what you have here when you do that. So it means after this, you can open the bracket. You open the bracket for that, and you open the bracket for this by FOIL. Add the like terms together. You're going to be having 3x squared minus 12x plus 11. Let's go to example 3. Sorry for that. In example 3, we have something a little bit different from the first two. Here we have two brackets there, and then separated by a negative sign, and then another, expression, one in the bracket and one outside the bracket. Now, to do this kind of question, we often take this as a product, which means you're going to apply the product rule to that term there, and then here also is a product. We also apply the product rule there. The answers we get for the two, we subtract from each other, as the sign there is saying. So I call this U1, I call this V1, I call this my U2, you don't need to take the negative, and I call this my V2, that's it there. And so I differentiate by the product rule the first two brackets, and I will take the second two expressions also as a product rule. Let's do the first one. So it means if I have to use my product rule, that is what I'm going to have in. Differentiate U1, hold V1 constant. Differentiate V1, hold U1 constant. That's the first one there. And then the second one there, differentiate U2, hold V2 constant. Add, differentiate V2, hold U1 constant. So if I differentiate that, which is my U1, I have that. If I differentiate that here, which is my V1, I have that. If I differentiate my U2, I have 0. If I differentiate that, I have that, which is 8x plus 2. And so if I apply that rule there, the product rule, I'm going to be having that, which is my U1 differentiated times V1 plus V1 differentiated times U1 plus my U2 differentiated times V2 plus my V2 differentiated times U2. If you open the bracket there and collect like terms, you're going to be having 12x to the power of 3 minus 18x squared plus 36x plus 14. That's all about the product rule. Let's now go on to the second rule, the quotient rule. The quotient rule is talking about rules of dividing algebraic expressions and differentiating them. Let's look at this. Given y equals to u over v, to differentiate a quotient, what we do is we square the denominator. That's the first step. Square the denominator. Hold the denominator constant. Differentiate the numerator, which is du dx. Don't forget we are differentiating with respect to x. You minus. You now hold the numerator constant. You differentiate the denominator. Now students must be careful not to do it other way around. You must not differentiate your denominator first. You must hold your denominator constant. And you differentiate your numerator first. You minus. You now differentiate your denominator afterwards, and you hold your numerator constant. That's the rule. Let's look at an example. Example 1. Given y equals to 2x minus 3 over 4x plus 1, what it's advisable is that you could represent the numerator as u and the denominator as v, so as to apply the rule there. And so you go ahead to differentiate each of them. Let's differentiate our u with respect to x. Differentiating u with respect to x will give us 2, as this becomes 1, and that becomes 0. Differentiating v with respect to x becomes 4, as this becomes 1 times that, and this becomes 0. So you have our differentials for the two expressions. Now we apply the rule. So you see me here squaring the denominator, that's the denominator, which is 4x plus 1 to the power of 2. Hold the denominator constant. You can see it's still there. I've not differentiated it. This is my du dx, which I've already differentiated there, the numerator. you minus, you now differentiate the denominator. If I differentiate that which I've done before, it gives me 4. Now I'll hold the numerator constant. And after you have done that, applying that rule there, you open the bracket on top only. It becomes 2 times 4x is 8x, 2 times 1 is 2, negative 4 times 2x is negative 8x, negative 4 times negative 3 is positive 12. You don't need to open the denominator bracket, it's fine. Now collect like terms there. If you do that, this will cancel out, the 8x will cancel out, and 2 plus 12 will give you 14 over that. And that becomes your answer. Let's look at another example. In example 2, the denominator is x to the power of 100 plus 7, and the numerator is 1. So let's take our numerator as u, which is equal to 1, and our denominator as v, which is equal to x to the power of 100 plus 7. Let's differentiate the u with respect to x, obviously. There's no x there, so this gives us a constant. The differentiation of a constant is 0, as you can remember. Let's differentiate that. That's a power rule. Bring the 100 down, minus 1 from that. So it becomes 100 to the power of x to the power of 99. The 7 becomes 0 when you differentiate it. Now, having done that, let's now apply the rule. You square the denominator, which is x to the power of 100 plus 7, bracket squared. Hold the denominator constant there. Differentiate the numerator, which you have already done, and that's 0. You multiply by 0, the differentiation of the numerator. You minus. Now differentiate the denominator, which you have already done there, that is it there, 100x to the power of 99 times the numerator that is held constant, which is 1. After doing that, you open the brackets on the numerator. If you open the bracket, it becomes 0, and this gives you negative 100x to the power of 99 over that. And that becomes your final answer. Let's go to thought 2 and look at the chain rule. In the chain rule, we'll be having 2 different functions, and one function is related here to u, and the u is related to x. Now the rule for the chain rule says it's a function of a function rule, which means that I can substitute this back here and I differentiate my y with respect to x, or rather I differentiate them on individually, dy du times du dx. If I do that and I should multiply them together, you see the du here will cancel out, so I'm still going to have my dy dx. Let's look at an example. In example 1 here, it says if y equals u squared minus 2u and u equals x squared minus x, find dy dx. Here, applying the rule here, the chain rule, it says to find my dy, relationship between y and x, I have to differentiate this on its own individually, differentiate this one again individually, and I will multiply the 2 answers. So let's differentiate y with respect to u. That's it there, dy du, and then we differentiate u with respect to x. The y du there is 2u minus 2, because this becomes 1, and that's it there. Differentiate du dx. It will be 2x minus 1, because x gives you 1. That's it there, 2x minus 1. So what you do now is that the 2 answers you have, for you to have your dy dx, you need to multiply them, as you have been told in the rule there. So if I multiply the 2 answers I'm having, that's it there. This is 2u minus 2 in bracket times 2x minus 1. Now, you need not open the bracket if you don't want to. All you need to do here is to make sure all the variables here are in relation to x. So I need to change that u by substituting u as x squared minus x. And that's what I did there, x squared minus x. If you leave your final answer like this, you should have your full marks, because all we are testing is for you to differentiate, and you have differentiated. But if you feel like expanding or opening the bracket, you are welcome to do so, but it is not necessary. Let's look at example 2. In example 2, here it says if y equals 1 over w squared, which also can be written as w to the power of minus 2, if this comes up as in your exponential rule, and w equals 2 minus x. We are told to find dy dx. So it means to find a relationship between the y there and the x here, we need to differentiate them one after the other. So let's differentiate the y du, the y dw, sorry. The y dw will come, use the 1 of the power form, bring minus 2 to the front, and minus 1 from that. It's going to give you minus 2w to the power of minus 3. At this point, you can bring this down using your rule of exponential rule of negative power, and then when you bring it down, it becomes a positive exponent. And then the next thing is to differentiate your w with respect to x. And if you differentiate that, the constant becomes 0. If you differentiate that, it becomes minus 1, and that's it there. So now to find your dy dx, it should be dy dw times the w dx, which is here. So it means I multiply this by that. And that's what I'm doing there. And I'm going to have negative and negative there. We cancel out to become positive. And then I replace my w back with 2 minus x, which is what I did there. And that's my final answer. As I've said, you need not to open the bracket. That's your answer. Let's look at example 3. In example 3, it says if w equals 3u squared and u equals to 2t plus 1 over t minus 1, find the w dt when t equals 1. Now here, the first thing to do is, as we have said, differentiate them one after the other. Let's differentiate the w du. The w du will give me 6u. And the next one will be the du dt. In differentiating du dt, I need to apply the quotient rule, because it's in quotient form. So I will square the denominator, if you remember, hold the denominator constant, differentiate the numerator, which gives you 2. If I differentiate 2t plus 1, it gives me 2. Minus, now differentiate the denominator, which is t minus 1. And that gives you 1. And then multiply by the numerator held constant. If you open the brackets on the numerator and collect like terms, you're going to be having minus 3 over t minus 1 to the power of 2. After that, you need to multiply the two answers, 6u times minus 3 over t minus 1 to the power of 2. And that's it there. So your dw dt will be that. And don't forget, always make sure you represent your u back to the variable which is with respect to that, which is t. So you represent that back by substituting for u, which is 2t plus 1 over t minus 1. And that's it there. At this function, you can now replace the t will be equal to 1. All the t values will be equal to 1. So it means if I substitute t as 1 there, I should have, let's do that here, is equal to 6, open bracket, you put in your fraction, which is 2 times 1 plus 1 over your t plus 1, which is 1 plus 1. 1 plus 1. Don't forget that is to the power of 2. So let's make it to the power of 2. So if I make it to the power of 2, I will have that. 1 plus 1 squared. Now don't forget this is to be multiplied by minus 3 over t plus 1 squared. So if I do put another fraction there, I'm going to have that minus 3 over t plus 1 squared, which is 1 plus, let's put a square there, and that gives me 1 brackets to the power of 2. And then if we do that with a calculator, the answer it gives us is what we have. So that would be 6 times 3 over 4 as 3 over 4 times minus 3, which is also in fraction. Let's put it in fraction there. Minus 3 over 1 plus 1 squared should also give you 4. So if you do that with your calculator, you should be having minus 54 over 16. Let's put that together. And then you can leave that in fraction, that will be fine. That's all about the first 3 principles of differentiation: the product rule, the quotient rule, and the chain rule. Thank you.